Okay, this video is a do now, or what I did was basically this is for Calculus 1 where we're talking about uh, finding the limit, and we're going to use more. Actually, I use more than two methods, but to show that you can find the limit in many different ways. So first of all, here I have this function, the limit as x approaches 0 of 1 over radical 9 plus x minus 1/3 all over x. And the first thing I did was graph this. So I'm going to bring up my graphing calculator, and then I brought up the table. So here's what my function looks like. And I'm approaching 0. So I put 0 in the middle of my table. I opened my table up and said, oh, I'm jeepers. At 0, the there is no value. The function is undefined at 0, even though you can't really see it here on this graph, but that's what it is. So I need to find the limit as x approaches 0. So as I come from this way and come from this way, it's going to be some value. Even though the y value doesn't exist, we can still find the limit. So while I'm highlighted on the table, I'm going to hit menu, and I'm going to do table, and then I'm going to edit my table settings, and I'm going to change my independent to ask, because this is what I've showed you in class, and it basically wipes our table out. And then I'm going to get really close to 0. So I'm going to do from the right 0.01, and then I'm going to do 0.001, and then I'm going to do 0.00001. So it looks like negative 0.815. This one is actually 815.81503. Then I'm going to come from the other side and do negative 0.01, negative 0.001, negative 0.00001. So it looks like it's going to be a negative 0.015 is my limit. So this is how I find my limit intuitive, and I believe that's what our limit's going to be. So keep that in mind as we do the algebra for this. So the first way I'm going to do this one is I'm going to do it with our old method where we actually used algebra to do this before I show you, because this whole lesson's on L'Hopital's rule. So the first thing I did is when I plug a 0 in for here, I get 1 over radical 9, which is 1/3 minus 1/3. So I get a 0 over 0. So I have my indeterminate form 0 over 0. So what I'm going to do now is just use some algebraic rules to see if we can get it into a spot to find the limit. Okay, so the first thing I'm going to do is I have a complex fraction going on here. So I'm going to multiply all these terms by the common denominator, which is 3 radical 9 plus x, 3 radical 9 plus x, 3 radical 9 plus x. And when I do that, I get the limit as x approaches 0 of, these cancel out, 3 minus, the 3's cancel, radical 9 plus x, all over 3x, radical 9 plus x, because nothing cancels out in the denominator. Now, if I plugged a 0 in here again, I'd still get a 3 minus the square root of 3. I'd still get a 0 over 0. So I'm going to use my next method is I'm going to multiply this by the conjugate of the numerator. So I'm going to multiply it by 3 plus radical 9 plus x, 3 plus radical 9 plus x. Okay? So when I do that, this makes this look like the following. Ready? I have the limit as x approaches 0. Now the numerator is going to look nice because that's the whole reason why I use the conjugate. The middle is going to be gone. So I have basically 3 times 3 is 9 minus, and then I've got radical 9 plus x times radical 9 plus x. That's plain old 9 plus x, but make sure you put it in parentheses. And the denominator is what looks awful. So I actually have 3x radical 9 plus x times 3 plus radical 9 plus x. Okay? So this is going to equal the limit. I'm just going to I can see some things I can do here as x approaches 0. And this really is 9 minus 9 minus x. So guess what cancels? The 9's do. So I really have a negative x all over 3x radical 9 plus x times 3 plus radical 9 plus x. Okay? Now, if you see it here, I've got a factor, 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 factor. So here I can cancel a divide to make a 1. So I'm wondering, I'm going to see what after all this algebra, if it helps me any. I've got the limit as x approaches 0 of negative 1 over 3 radical 9 plus x times 3 plus radical 9 plus x. Okay? Now, when I plug a 0 in, because now it looks like I can, I've got negative 1 over 3 times 9 plus 0, radical 9 plus 0, times 3 plus radical 9 plus 0. So I have negative 1 over here. Underneath here, I have a 3 times a 3, parentheses 3 plus 3. So I have 9 times 6, or 54. And guess what? When I put that in my calculator, and you guessed it, it's going to be this value here. It's negative 0.0185. So I just found the limit algebraically, which is what we found intuitively. So there's two methods right now. Now, this third method is what we're looking at, is we're going to start using a new method called L'Hopital's. And L'Hopital's method is you have to have the indeterminate form of 0 over 0, or positive and negative infinity over positive or negative infinity. Those are my two indeterminate forms. If I have that, we can use L'Hopital's rule, which is we're going to use it by doing the derivative of the numerator and derivative of the denominator. But you have to have the indeterminate form. So again, I'm plugging this 0 in. I get 1/3 minus 1/3. I do have 0 over 0. So now I can begin to use L'Hopital's rule. So this is going to be the limit as x approaches 0. And then, if you will, please, we can actually look at this as 9 plus x to the negative 1/2. So I'm just kind of rewriting that, how we can look at that. So I'm just going to rewrite it first before we do it. So this is, I'm just rewriting it. It's 9 plus x to the negative 1/2 minus 1/3 all over x. Okay, so now we're going to actually start doing the derivative of the numerator. So I have the limit as x approaches 0 is going to be, ready, negative 1/2, because it's a power rule, don't touch the baby, to the negative 3/2 times 1. And this is a constant, negative 1/3, and the derivative of x is 1. I'm like, okay. So I'm going to kind of rewrite this so a little bit nicer. So this is going to be the limit as x approaches 0 of, so I've got a negative 1 over 2, 9 plus x to the 3/2, just so you can look at it nicer. Now I'm going to plug the 0 in to see what we get. And I know we have a number here, so I know I'm done with L'Hopital, so I'm just going to actually throw a 0 in that spot. So it's going to equal negative 1 over 2 times 9 plus 0 to the 3/2. And guess what that is? It's negative 1 over 54. So out of the two methods that I showed you algebraically, this is much shorter, and you can only use it because we had the indeterminate form of 0 over 0. So I hope this helps. See you in